Hello everyone, welcome to the YouTube channel of TriboNet. My name is Manoj. Today, in this video, let us learn about mechanism of metallic friction as described by Bowden and Tabor. Kinetic friction is influenced by factors like hardness and melting points rather than just surface characteristics. Hence, friction depends on bulk material properties. Even polished surfaces have irregularities, and friction arises from adhesion and shearing of the softer material under pressure. While friction generates heat, high ambient temperatures do not necessarily increase friction. Instead, it depends on the load, speed, localized heating during sliding. Here in this figure, we can see the representation of sharp probe making an asperity contact. Friction of metal in hard on soft surface. The relationship between frictional force, contact area and applied load has been extensively studied. Coulomb and Amundsen formulated two key laws. Frictional force is independent of the apparent contact area and it is proportional to applied load. While these laws initially lacked a theoretical basis, studies on the real area of contact have provided explanations with respect to the first law. Various experiments revealed that the real area of contact between metals was measured using electrical conductance techniques. The findings revealed that contact occurs primarily at the summits of the surface asperities, resulting in a real contact area that is significantly smaller and largely independent of the apparent contact area. This insight helps to explain why the frictional force is unaffected by changes in the apparent contact area as the real contact area and consequently the frictional force, which remains consistent under the similar loading conditions. Further, Amundsen's second law, which states that the frictional force is proportional to the applied load, initially posed challenges because it was assumed that the surfaces deformed elastically. Elastic deformation would predict the contact area and thus the frictional force to vary with the 2/3 power of the load, not linearly. However, conductivity measurements revealed that the surface deformation is predominantly plastic. Under plastic deformation, the material flows until the contact area becomes proportional to the applied load, resolving this inconsistency. Effect of contaminating film with friction. Under most experimental conditions, the metallic surfaces are covered within the thin oxide layers and contaminating films. During sliding, these films are withered, allowing some metallic contact leading to penetration of the surface irregularities through them. However, the adhesion and shear strength at these junctions are lower than those of pure metal. Effect of intermittent motion on friction. It has been studied that when any moving system has significant elastic freedom, this motion may become intermittent, progressing via stick-slip behavior. This occurs because the kinetic friction during slipping is lower than the static friction during sticking. The type of sliding is strongly influenced by the properties of the metals and lubricant films, as well as the mechanical characteristics of the system, such as natural frequency, moment of inertia, and damping. Friction of metallic films. In the earlier experiments, Amundsen's law was observed because changes in the load naturally cause proportional changes in the area of contact, preventing independent variation of these factors. This limitation can be overcome by using a hard steel substrate coated with a thin layer of soft material such as indium. When a hemispherical slider is placed on this surface and different loads are applied, the slider sinks into the indium until the load is supported by the underlying steel. Since the steel deforms minimally, under further increase in load, the contact area between the slider and the indium remains largely unaffected, enabling independent control of the load and contact area. These are the references for the information provided in this video. In this video, we understood the introduction to the mechanism of metallic friction as described by Bowden and Tabor, the friction in the metal in hard on soft surface, effect of contaminating film with the friction, effect of intermittent motion on friction, and friction of metallic films. Thank you for watching this video, and to get more details on the topics related to tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel TriboNet. Also visit our website on www.tribonet.org.